you have 0.0853 for steel moment resisting frame, 0.0731 for reinforced concrete moment resisting frame, and 0.0488 for all other buildings. So kini ato reinforced concrete man no nga moment frame, therefore we use 0.0731. So that is the value that we have adapted here. Okay. So after having all these seismic parameters, then we can proceed to calculate the base shear. So in the code, under seismic zone 4, there are 4 formulas for the base shear, no? So makita na to na diri ang upat ka formula. Ini, no? So ingon diri total design base shear in a given direction shall be determined from the following equation. So equation 28-8, then need not exceed the following. So this is the maximum, no? 28-9, and then shall not be less than the value obtained by using this equation. So this is the minimum, no? So maximum, minimum, and additional nga kining minimum for seismic zone 4 given by equation 28-11. Okay? So muna siya nga itong i-apply dire. We calculate the fundamental period. So mo itong formula nga ito nakita dire, no? For determining the fundamental period, there are two methods. We have method A and method B. So in this solution, what I have shown is method A. Because muna siya masayon ang method B. Dako pa na nga trabaho kay kinanglan kabalutan ni ini mga no? Dako pa ni komputulon. So we just use here method A, which gives us this empirical formula for determining the fundamental period. So you have T is equal to CT times Hn raised to the power 3/4, where Hn is the height of the building, no? From ground level to the roof deck level. So that is the formula we have used here. So CT 0.0731 and the height of the building 9 raised to the 3/4, we get 0.38 second. Is the fundamental period. Then we apply the 4 formulas, no? So equation, walang nausap na sigurong numbering sa kining magyapon 28-8, let's see. Usap na gamay ang numbering, no? Kaya diri 28-8 to 28-11 naman, no? Anyway, the formula are still the same. Numero, ang numbering lang sa formula mo ay nausap, no? So the first equation, you have CBI over RT times W. So ang kaning CBI, R o kaning tulo, no? Our seismic parameter, kaning T mo na siyang bago pa lang na compute dire. So you just substitute the values here. So you get your base shear as a percentage of the weight. And we also use the next equation, 2.5 CAI over R times W, which gives you 0.1294 W. Then we have here the minimum, no? 0.11 CAI W, the value sa CA sa I. Then we get 0.0484. An additional equation to be checked, no? For buildings within seismic zone 4. 0.8 Z NVI over R. So na naman tayo Z NVI ng tayo R. So compute sa tani. So asa may mag-govern ini? Kani siya mo ni atong unang equation kani maximum. Kaputa na kini nilapas ba ni ini? Ha? Nilapas, no? Lapas. So mo na yung maximum. So this equation overestimated the magnitude of the base shear. So, kini siya, dili ni siya mag-govern. Kani mag-govern, kini siya mas dako ba sa minimum? Mas dako, no? Kini siya mas dako ba sa nining line minimum? Yes, so ito pa kani siya mo govern. Okay? Then we now substitute W from the building data, no? So you have 8,083 kilonewton to get this answer. So makita na to dere, no, nga kini siyang calculation are iterative Kaya sa pag-compute na to nining total dead load sa building, this is based on the assumed sizes of the girders and the columns, which might be different, no, once you've already designed them. So, mo nang simple nga dagko ra nga atong i-assume nga size, so dagko ra sad nga base year nga atong ma-compute. So ato na siyang balikan, no? O panalitan gamay ra sa nga atong na-assume nga mga sizes, nga mogawas nga dagko di ay, then importante sad nga balikan nato, no? Kay pag-adjust na to sa mga forces. So manually done, this is quite tedious to do, no? Kay iterative nga procedure man, but using Excel, when it is linked already, then this will be easy. Now the next step will be to distribute the base shear to the different levels of the building, no? So dito lang ta diri sa representation niya, no? So naa diri nga atong base shear. This is the shear at the base, no? Ito siya base shear. Naa diri V. Ya ang sunod natong buhaton ato nang i-distribute nito sa different levels. So how much of the base shear is acting at the roof deck level, at the third floor level, and at the second floor level. So that is the purpose. Ini gitawag na itong vertical distribution of forces. Now, natay force due to whiplash effect, which is applied at the roof deck level, no? So it is 0 when the fundamental period of the building is less than or equal to 0.7. It is 0.0 TV when the period is between 0.7 and 3.6. It is 0.25 V when the period is greater than or equal to 3.6 seconds. So as you can observe, no? So ang atong fundamental period proportionate siya sa height sa imong building. So taller buildings would have a longer period compared to shorter buildings. No? So kung magpuyo ka o kining condominium nga high-rise, panahon sa linog, dugay kayo ang Leox building, no? Hindi siya. Hinay kay iyang tabiyok, no? Kaya taas man ang iyang period. Kung naara ka magpuyo ka sa dormitory, 2-story, paspas kayo, no? Kurog kayo, di ba? So asa man ka diya? Adto sa hinay ang tuya o kaning sa paspas nga kurog? Ha? O, ikaw na lang pag-igo diya, no? Ikaw lang bahala diya. Unaw na agmayo, no? So makita na to nga sa mga very tall buildings, the force due to whiplash effect is significant, no? 0.25 of the base shear. So 25% of the base shear is applied at the roof deck level, no? And the rest will be distributed at the intermediate floors, no? So remaining portion of the base shear shall be distributed by, so according to this formula, I think that is also given, no? There is a one. Monitoring, no? Sa vertical distribution, monitor ang equation. Itong gigamit. So, V minus Ft, that is the remaining force to be distributed, no? At the intermediate level, kaya ang Ft, muna siyang i-apply na to sa top. Now, in this case, no, kaya nga itong period 0.38 seconds naman, mubuo naman nga itong building, 3 stories, high naman siya. So, gamay siya period less than 0.7, and therefore the force due to whiplash effect is 0, no? So kung 0, then wala ni siya, then V will be distributed proportionately, no? To the weight at that particular level and the height of that level. So pananglit ko ng imong weight are equal, no? Sa second, third, yung roof deck, parihan sila weight, yung imong height is regular, so 369, then the distribution will be linear, no? In the form of an inverted triangle. The largest being at the top and the smallest at the lowermost floor. Pero dili kay dili man equal nga atong floor nga weight, no? Second o third equal, pero ang roof deck medyo lahi. So magpaabot nga dili gini siya tuliid nga pagka-triangle, no? Now, to facilitate in the calculation, we can prepare a tabulated solution, no? So, in the table we have here the first column floor level, so starting with roof deck, third floor, second floor, and ground floor level. Then you tabulate the weight at that particular level. So, this is the weight of the roof deck, third floor, and second floor. Ground floor not included, no? So, kung atong building doon ay basement, tuwa sa appeal. Ng basement. So, good kakwinta sa ground floor level, no? Then the height, so at roof deck 9, at third floor 6, at second floor 3, at ground level 0. Then in the formula, you need to calculate ini siyang WIHI. So that is simply the weight at that particular level multiplied by the height, no, at that level. So there is a table, you just multiply this value to this value here, no, to get the values in this column. Then kani nga mga values imo na siyang i-add, no, to obtain your summation. Kaning denominator na rin, no, summation WIHI. So we have here the sum. So this value divided by this multiplied by V minus FT, in this case FT 0, no, in this problem. So you have only V, so you get 530, then 16,013 divided by 48,724 times the base year, you get 344. So the same ratio multiplied by 8,007, you get 172. No? So sa pagkakaroon, ang importante kini siyang lateral force na to, ay sa mo kay kapalakan nining video game. Pwede na sa nato sa pagkakaroon kalimtan sana na to, no? Kaya wala na igamit. So I have also shown here a detailed calculation. So yun sa nag-obtain kining 530, 344, 172 for you to easily follow. Okay? Then story shears. So you have the shear at the top 0, then shear at the lower level will be equal to the shear at the upper level plus the lateral force at that level. So monitor is 0 plus 530, you get 530, 530 plus 344, 874, 874 plus 172, you get 1046. And of course, to check your calculation, the shear at the lowermost level, that is ground level, must be equal to the base shear, no? And equal siya ng base shear. Kaya kung dili, malagbing na kay sayop sa imong pag-compute. Okay, so if let's copy this table. So na si Tupa dire para masabta na to ang iyang interpretation. So mo rin dire, no? So this is the base shear, then the lateral force applied at the roof deck level is 530 kilonewton. At the third floor level, mo rin 344 kilonewton. At the second floor level, you have 172 kilonewton. So that's your vertical force distribution. So do na by question?